Question 1. Given the equation x squared minus 4ax plus 5b is equal to 0 has two real and equal roots, express a in terms of b. The quadratic equation is x squared minus 4ax plus 5b is equal to 0. A is equal to 1, b is equal to negative 4a, and c is equal to 5b. We are also told that the equation has two real and equal roots, implies that b squared minus 4ac is equal to 0. So let's continue from here. B squared minus 4ac is equal to 0. Negative 4a squared minus 4 times 1 times 5b is equal to 0. Expand the bracket. 16a squared minus 20b is equal to 0. We are asked to express a in terms of b. Therefore, 16a squared is equal to 20b. A squared is equal to 20b divided by 16. Simplify the equation, we get a squared equal to 5b over 4. Therefore, a is equal to plus minus square root of 5b over 4. Question 2. Find the range of values of k if the equation x squared plus k equal to kx minus 3 has two real and distinct roots. State the values of k if the equation has two real and equal roots. The quadratic equation is x squared plus k is equal to kx minus 3. Rearrange it into the general form. X squared minus kx plus k plus 3 is equal to 0. A is equal to 1, b is equal to negative k, c is equal to k plus 3. The question also states that the equation has two real and distinct roots. This implies that b squared minus 4ac is greater than 0. Let's find the range of value of k. B squared minus 4ac greater than 0. Negative k squared minus 4 times 1 times k plus 3 is greater than 0. Expand the inequality. K squared minus 4k minus 12 is greater than 0. This is quadratic inequality. Let's factorize it. K squared can be separated into k and k. 12 is 1 and 12, 2 and 6, 3 and 4. We need to get a negative 4k over here. This combination will give us a 4. So 2 and 6. In order to get negative 4k, we minus 6k plus 2k. And we check plus and minus, we will obtain a minus here. Then we solve for the quadratic equation, k plus 2, k minus 6 equal to 0. We get k plus 2 equal to 0, k equal to negative 2, or k minus 6 equal to 0, k equal to 6. We sketch the curve. We have a positive k square, so it is a smiling curve. And the intersection point is negative 2 and 6. Since the inequality is greater than 0, so we obtain the value above the curve. The range of values of k is k is less than negative 2, k is greater than 6. For the second part, we are asked to state the values of k if the equation has two real and equal roots. This implies that b squared minus 4ac is equal to 0. In order for the equation to have two real and equal roots, the k must be negative 2 and also 6. Question 3. The quadratic equation x squared plus hx plus k equal to 0 has roots negative 2 and 6. Find the value of h and of k. This part is actually from the previous section. Let's find the sum of root and product of root. Sum of root is equal to negative 2 plus 6, which is equal to negative b over a, negative h. 4 is equal to negative h is equal to negative 4. Product of root is equal to negative 2 times 6 equal to c over a, k. Therefore, k is equal to negative 12. The complete quadratic equation is x squared minus 4x minus 12 equal to 0. B. Find the range of values of c such that the equation x squared plus hx plus k equal to c has no real root. X squared minus 4x minus 12 equal to c. Rearrange it. X squared minus 4x minus 12 minus c equal to 0. Our a is a 1, b is a negative 4, c is negative 12 minus c. No real roots implies that b squared minus 4ac less than 0. Substitute in all the values. Negative 4 squared minus 4 times 1 times negative 12 minus c less than 0. Expand the inequality. 16 plus 48 plus 4c is less than 0. 64 plus 4c is less than 0. Therefore, 4c is less than negative 64. c is less than negative 64 divided by 4. c is less than negative 16. Question 4. Show that the roots of the quadratic equation px squared minus 3x minus p equal to 0 are real and distinct for all values of p. In order to show that the roots are real and distinct, we need to show that b squared minus 4ac is greater than 0 for all values of p. The equation is px squared minus 3x minus p equal to 0. A is a p, b is negative 3, c is negative p. b squared minus 4ac is equal to negative 3 squared minus 4 times p times negative p, which is equal to 9 plus 4p squared. P squared is always greater than 0. Any value square is always greater than 0. Therefore, 4p squared will also always greater than 0. 9 plus 4p squared will also greater than 0 because 9 is a positive value. Therefore, b squared minus 4ac is greater than 0. Hence, the roots are real and distinct for all values of p. Question 5. The quadratic equation x squared plus bx plus c equal to 0, where b and c are positive integers, has a discriminant of 16 and b minus c is equal to negative 4. The quadratic equation is x squared plus bx plus c equal to 0. b and c are positive. Discriminant is 16. b squared minus 4ac is 16. And also b minus c is negative 4. A. Find the possible values of b and c. We need to solve the simultaneous equation for these two equations. Let this be equation 1. For b minus c equal to negative 4, I'm going to make b the subject so that we can use substitution method to solve the simultaneous equation. So b is equal to c minus 4. Equation 2. Substitute equation 2 into equation 1. C minus 4 square minus 4. A is actually a 1. C is equal to 16. Expand the equation. C square minus 8c plus 16 minus 4c minus 16 is equal to 0. Simplify the equation. C square minus 12c plus 16 minus 16 is gone is equal to 0. Factorize it. C bracket c minus 12 is equal to 0. Therefore, c is equal to 0 or c minus 12 equal to 0, c equal to 12. And we are told that b and c are positive integers. C equal to 0 is invalid. Then we substitute c equal to 12 into either equation 1 or equation 2. Here I choose equation 2. B is equal to 12 minus 4 is equal to 8. B. Find the corresponding roots of the equation. Now we have the complete quadratic equation, which is x squared plus 8x plus 12 is equal to 0. We are asked to find the roots. Let's factorize the quadratic equation. X squared is x and x. 12 is 1 and 12, 2 and 6, 3 and 4. We need to get a positive 8x. 2 and 6 will give us a 8. In order to get positive 8 plus 2x plus 6x. And lastly, we need to check positive and positive. We will obtain a positive. Then we continue. X plus 2 is equal to 0. X is equal to negative 2. Or x plus 6 is equal to 0. X is equal to negative 6. So the roots are negative 2 and negative 6.